We are the third and final item in sequences, and that's geometric sequences. A sequence in which the ratio between any two terms is constant. That means you multiply by the same number to get the next term. The common ratio is the numerical ratio between any two terms, variable r. To find variable r, let's see, you divide a sub n plus 1 by a sub n, and that will give you r. So when we look here, determine whether the sequence is geometric. If yes, identify the common ratio and give the next three terms. Well, I have to do 12 divided by 6, 24 divided by 12, and 48 divided by 24. So 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. Now, since it's all the same, it's a common ratio, so my r is equal to the 2. Now, how do I find the next three terms? Well, I do 48 times 2, and I wind up with 96. Then I do 96 times 2, and I get 192, and then I do 192 times 2, and I get 384. That's all there is to it. Now, what if when I do all this division it's not the same? Then you just say no. Right now you're just being asked about geometric. Later on you'll be asked to check for arithmetic and then geometric and then go on. Try number 2. You're back? And remember, when I say to try it, I'm telling you to pause the video, try to do to number 2 what I did to number 1, and then come back. All right. Did you divide 270 by 810, 90 by 270, 30 by 90? If you did, you should find that yes, your ratio is 1/3. Then you can do 30 times 1/3. You're going to get 10. And then 10 times 1/3. And then 10/3 times 1/3. So remember that when you did 10 times 1/3, you multiply your numerators, which is why you get the 10 over the 3. Then 10 over 3 times 1 over 3. 10 times 1 is 10. 3 times 3 is 9. If I kept going, I would have 10 over 27, and so on. Okay? Now, if we'll continue on, we're going to look at 3, 4, 5, 6, 7, and 8. These are all the same. These are just asking you to check, is it a geometric sequence? And if it is, to find the next three terms. So at this point in time, pause the video and try 3 through 8. All right, you back? There we go. There's 3, there's 4, there's 5, there's 6, there's 7, and there's 8. What do you think? If you had problems with any of these, please come in and see me. But essentially, you're finding R, okay, you're checking for R by doing each a sub n divided by, a sub n minus 1. Terrible writing there. Okay, so you do that for all of them. If it's not the same, like 8 divided by 4, 20 divided by 8, not equal, so we got the no. 4 divided by 2, 16 divided by 4, not equal, that's where you get the no. Okay? And then you keep going. And once you find the r, you simply multiply that r, which gets big. I mean, this 235,298, yeah, it's big, but you can do it. You'd have a calculator. I wouldn't ask you to do something like that without a calculator. Okay? Now, let's move on and look at the geometric sequence formula. So when we're looking at this sequence formula, it too is on the formula sheet for the SOL, and so will be provided to you for tests and quizzes. A sub 1 is the first term, and r is your common ratio. We need to write a rule for each sequence, then find a sub 6. In this particular case, for things like 9 and 10 and such, I'm actually telling you that it is a geometric sequence, and so you can find the r just by doing 5 divided by 1, or 65 divided by 130. And then write the rule. You know what a sub 1 is. What is a sub 1? Right here. A sub 1 is equal to 1. Okay? R is equal to 5 divided by 1, which is 5. So now a sub n is equal to 1 times r to the n minus 1. You don't need the 1 there. And then you can find a sub 6 by plugging in a sub 6 is equal to 5 to the 6 minus 1, or 5 to the 5th. And yet, you might have to use your calculator to figure out that's 3,125. All right? Pause the video. And you have numbers 10, 11, 12, 13, and 14 to try. Okay? Again, they're all the same. Just look at your list and boom, right there you have a sub 1. You divide the second term by the first term and you've got your r. And then you can keep going. All right? Did you get the right thing here? Good. And if you need to, pause that video and look at that, or rewind it. And now, come back and look at 11, 12, 13, and 14. Did you get these all correct? Pause the video, check your answers, check your work. If you need to, bring it in and ask questions. Let's move to the next section. Here you're going to use the information given to find the indicated value. I've got a sub 1 is 7 and r is 4. I need to find a sub 8. That should be easy. Number 16, you're given a sub 5 and r, and you need a sub 1. That's okay. Remember, you're given, whoops, go back here because I'm writing so terrible. Okay. You're given a sub n is equal to a sub 1 times r to the n minus 1. A sub 1 times r to the n minus 1. So, a sub 1 times r to the n minus 1. So if I give you a sub n, negative 68, I don't know a sub 1. I know r is negative 0.5, and I know that n is 5, so it's 5 minus 1. I can go through now and simply solve for a sub 1. You're still given 2 of the 4 pieces of information. Okay? Now over here, a sub 1 and a sub 4, use these to find r. Once you have r, find a sub 3. Same thing here, a sub 2. Okay, pretend like if you've got a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. But I know these. Well, then couldn't this be 1, 2, 3, 4? So just change the subscript here, find r, and then you can find a sub 3 or go back and find a sub 4, whichever. Right? Try these, and then I'll come back and expose them. This is a little bit of problem solving. These are getting a little bit more difficult. Not crazy difficult, but a little bit of thinking. Seriously, pause the video. Okay, I'm going to trust that you paused it and you're back and you're ready to look. This, straightforward. This one, again, pretty straightforward. You just plug numbers in and solved. Now, 17 got a little bit crazier because we needed to use a sub 1 and a sub 4 to find r. Then we used the r to find a sub 3. So it was a two-step. Still wasn't crazy because r was straightforward, but a sub 3 was had to do that extra step. 18, this is one that's a little bit crazy, okay, because we're going to pretend like a sub 2 is a sub 1 and then a sub 5 is a sub 4. Okay, and that's why you've got the 3 up there. Yeah. Takes a little bit of finagling, but remember you can do it. You're just taking a subset of your sequence. Okay? Now, here's an application because you do have to apply all this information. Jackson bought a brand new car for $38,000. If the car depreciates, that means it loses value by 20% each year. What will the car be worth in 8 years? Now this is more realistic than when you were in Algebra 1 and we said your car loses $5,000 every year, because it's usually not straight line. Usually it loses a percent. So think about 8 years later, it's worth less. But now here's something interesting. First off, I can put the 8 in up here. That's easy. And my A1, well, it was 38,000. Now, it's losing 20% each year. But that means that, if you think about it, year 2 is 80% of year 1, right? Not 20%. So it's losing 20% each year, but it still has 80%. That's why my R value is not 0.2, but 0.8. That's the only tricky part here. Once you realize that, just plug it all in and boom, there's your answer. Your $38,000 car, 8 years later, is only worth $7,969.18. Kind of a hard one to swallow, but it's there. Now, at this point, you are prepared to complete homework 3, Geometric Sequences. It has basic problems 1 through 18, and then 19 and 20 are applications. That's it for sequences. Next up is lesson 2 and series.